we have started with OSPF and that basics of OSPF. Yesterday we have discussed that OSPF is intra-domain routing protocol, uh, which works in one autonomous system, and autonomous system can be divided in multiple areas, and area 0 is known as backbone area. So yesterday we have covered all the basics. So now today we'll see how to configure OSPF and how to configure OSPF for different areas. So in this configuration or in this topology, you can observe I have configured two areas here, area 0 and area 1. So this router will act as, that is router 5 will act as area border router. I have just given IP addresses to this PCs, and all the interfaces I have configured with whatever is the requirement. Only the routing protocol is remaining to configure here. So meanwhile, everybody will join, so we'll see if the IPs are given or not. So you can see here, this is how many networks are there first, that we'll see. So this is network 10, then network 20, 30, 40, 50, 60, 70, 80, and network 90. Means there are total 9 networks. So this is network 10. So which IP is given to PC, that I can check even by clicking on PC desktop. You can check the IP or just put the cursor. So 10.0.0.2 I have given, and gateway is 10.0.0.1. So that gateway address is nothing but address given to this router interface. This interface will act as a gateway, as everybody is aware with that, because we have already implemented RIP v1 and v2, and in that we have configured that routing protocol. So everybody is familiar with that, where to enter gateway address and what's the role of that gateway address and gateway. You are aware with that. So every now this PC, which is having that, even you can check here that 90.0.0.2 subnet mask is provided, as I've used here classful addressing. So that is subnet mask, as it belongs to class A, subnet mask is 255.0.0.0. Even OSPF support for classless addressing, you can try for that also. Now this is network 40. So this interface is that FA 0/0. This interface is configured. That address is you can check here by clicking on this FA 0/0. So 40.0.0.1. So what I want to say is I have already configured IP addresses to all the interfaces. So likewise, all the networks are configured. So you can see only 3 pieces are connected, and pieces are directly connected to the router. That is also okay. So now we'll configure routing protocol. Click on the router. As yesterday we have discussed, there are 5 modes. So CLI, now we are in CLI mode. So maximize it. Now we are in which mode? Specific configuration mode. So specific configuration mode, while configuring router, you should not be in a specific configuration mode. So just exit from that mode. So now we are in global configuration mode. So we can configure any router here in a global configuration mode. So command for that is router, then just give the question mark. So it is giving list of routing protocols. So router OSPF we need to give. So OSPF, and here we need to give process ID. In RIP there is no need to give the process ID, but in OSPF we need to provide process ID. You can give different process ID from 1 to 65535. So I will give here process ID 1. So press enter. Now next task is we need to add the network. So first we'll check which networks are directly connected to that router. So which networks are directly connected to the router? 10, 40, and this one is 20. So 10, 20, 40, these three networks we need to add. Even how to add the network, it is not as usual method which we have used in RIP. So the command is little bit different. So network, then next is 10.0.0.0. So this is network address which is directly connected to that router 0. Now the next press question mark. So it is asking for wildcard mask, and if you remember, we have completed what is wildcard mask in access control list assignment. So wildcard mask is what, which is reverse of the subnet mask. It belongs to class A. So network mask for class A is 255.0.0.0. So wildcard for class A is 0.255.255.255. So next is wildcard mask. Now the next that we need to give area. As autonomous system is divided into different area, we need to define whether the router is in which area. So that we need to define. So area word should be there. Now give question mark. So it will give you that OSPF area ID. There are again two ways. You can give that ID in IP address format, or you can give that ID in a decimal value. So that area number I need to mention, and there is no autonomous system without area 0. So autonomous systems should have area 0, and that area 0 will be known as backbone area. So area 0 I have given here. So now likewise, next two networks which are directly connected. So 20 was there, and the next I think that was 40. So 10, 20 and 40. So this is a configuration of, we can say, OSPF protocol on that router. So on one router we have finished. So now we'll take this router 1. So router 1, how many networks are directly connected? 3 again. So 20, 30 and 90. By using same process, we can configure it. So again, same procedure, conf t. So router OSPF process ID is 1, and we need to give same process ID. Okay, we can give a different process ID, but that is again for collection of router. So here we will maintain one process ID, that is process ID 1. So next command, that is network. 20 was directly connected, so 20.0.0.0. Then wildcard is 0.255.255.255. Then area word and area 0. Same. Now you can observe here, immediately the message come, it has found one neighbor. So adjacency it will found. So adjacent neighbor is 40.0.0.1 here. So adjacency is found here. Click enter. Then next network. While adding network, you should be very careful. Next network is 30. Am I right? Next network is 20, 30 and 90, right? So again, that is in the same area. So click on enter. Now just wait for some time. It will find if any adjacency is there. That is in area 0 only. So again, this second router is also configured. So now router 0, router 1 is configured. Now we'll configure router 5, and network IDs are 30, 40, 50, 60. same procedure. Come router OSPF-1 network ID 30 40 50 60. So 30.0.0.0 wildcard 0.255.255.255. So but while configuring this, you should be very careful. Why? Because now you can see here I have divided this topology in two different areas, area 0 and area 1. So area 0, that 40 interfaces connected to area 0, 30 interfaces connected to area 0. So these two interfaces are in area 0. While configuring 50 and 60, you need to give area 1. So 30 is in area 0. So area 0. Again, we'll repeat for 40. So 30, 40, we have completed here. It found adjacency. So next is network 50. I'll make here area 1. So 50, that is in area 1. Next is network 60. 60, that is also in area 1. So here we have configured this router also. Now router 3 and router 4 is remaining. So now we'll configure router 3. So this network is 50 and 70. Definitely now all these networks which are in area 1. So router 3 directly connected to network to router 3, those are 50 and 70. So click on the router, go into the CLI mode and maximize it, enable conf t, then router OSPF-1. Okay, so next command, that is network, and which networks are directly connected to that? That is /50 and 70. So network 50.0.0.0, then 0.255.255.255, then area 1. Next network, that is 70. So 50 and 70 is configured on this router in area 1. Now only one router is remaining, that is router 4. So router 4 directly connected network 60, 70, 80 all are in area 1. 60, 70, 80. So conf t OSPF router process ID 1. So router OSPF, router OSPF process ID 1. Next command, that is 60, 70, 80 we need to add. So network 60.0.0.0 wildcard 0.255.255.255 area 1. So if any adjacency found, we'll check. Then next is 70. So adjacent neighbor found. Next is 80. So here we have configured OSPF protocol on each router. And this topology is divided into area 1 and area 0. Now we'll see some basic commands. First we'll check whether we are able to transmit the data or not. So we'll first check the transmission from this PC to router. It's successful. From PC to mid router, it's successful. Then from PC to this router, it is successful. PC to next router, it's successful. PC to this PC might be failed first. PC 1 to PC 2, it is successful. Then PC 0 to PC 2, it is successful. So successfully we have configured this topology with different area. Now click on router 0. I have clicked on router 0 and we are in CLI mode. So first we'll check that show IP protocols. So it is giving you the information about that OSPF protocol. We have used OSPF protocol. Version of that protocol is 1, and routing for these networks, these many networks, these are directly connected to networks to that router 0, and these are what gateways. That is 40. You might have observed that it immediately gives, while configuring only, it immediately gives the adjacent neighbor. So these are the neighbors of these networks. So a distance, that is nothing but administrative distance. Administrative distance is 110. In RIP, it is 120. Next command, that is show IP route. Show IP route we have discussed yesterday. As we have studied in OSPF protocol, that is hello. Hello packets are used to basically discover the neighbors, right? So we can set the hello interval also. Even you can see here, if I give command show IP route. Show IP route is to display the routing table. So routing table, yesterday I have shown you the routing table, but yesterday we have configured the topology in this within all the routers were within the same area. Now here these routers IA, that is what inter area. So to router 0, 3 networks are directly connected, that is 10, 20 and 40. And network 30 is connected via this 40.0.0.2, and protocol implemented is OSPF, that's why O is here. Now 50, 60, 70, 80, those are in area 1, those are not in area 0. So that's why here IA comes. That IA means what? OSPF inter area. Routing protocol implemented is OSPF only, but that is not within the same area. Those are inter area routers. Right, so 50, 60, 70, 80. So these networks are inter area networks. 90 is within the same area, that is O, but it is not directly connected to that router. So that is also implemented by using OSPF. That's why O is here. Total 9 networks. Out of 9, 3 are directly connected and remaining 6 are connected by using OSPF protocol via some gateway or via some exit point that is given here, that is 40.0.0.2. So you can observe here the cost is 2, and even I have told you yesterday how to calculate the cost, that is 10 raised to 8 divided by reference bandwidth, or we can say bandwidth of that particular interface in bytes per second. So if it is 100 Mbps, if that link is of 100 Mbps, then bandwidth cost of that link is 1, because the bandwidth is converted here into bytes. So 100 Mbps, that is 10 raised to 8 itself. Serial link, in this part yesterday I have told you 1544, it's a default bandwidth, so that is in kbps, so it is converted into bytes per second. So 3 zeros are added here, and that is 64, right? So now we will see this cost, that is how it is 66. So that is network 70. So we'll see in the topology network 70. Now this is network 70, and we are now checking show IP route command on this router 0. So to go to network 70, this path is available, right? Or via this can go via 40, 50, 70, and this can go via 40, 60, and 70. 50 and 60 both are using fast Ethernet only. So cost of this link is 1 only. Cost of the link which is connected router 0 and router 5, that is 1, because it's a fast Ethernet link. Next is also fast Ethernet link. So that is 1. 1 plus 1, 2. And this link is serial link. So serial link default bandwidth, that is 1544, and in that case cost is 64. So 64 plus 2, that is 66. So you can observe here cost is 66. Right. Now the next is 80 and 90, cost is 3. So go again in the topology, network 80. So path can be via that 10, 40, from this router, that is 40, 60, and 80. So 1 plus 1 plus 1, that is 3. Even to reach to 90 network, that cost can be via 40, 30, 90. Why it is not choosing this path? Why this serial interface is not chosen? Because this bandwidth, fast Ethernet bandwidth, is more than that this serial interface. So we can even check that. Now if you give command on this PC, that is PC command prompt, if you give tracert you have already used, right? Tracert command. So tracert, and now I want to check path to this PC. So this PC IP, that is 90.0.0.2, right? So again I will click on this PC, tracert 90.0.0.2. So check the path. So path is something like 10, then 40, then 30, and 90. So it is coming, packet is coming from this PC1 to router 0, to router 5, to router 1, and then PC0. Now we'll check how we can make the packet to transfer by using this serial link. So click on the router and go into the CLI mode, just maximize it. So now, yesterday I have told you one command, show interfaces, right? Show interfaces. So here it is, it will show you all the interfaces of that router. Now first is fast Ethernet 0/0. So this bandwidth is 100 Mbps, that is given here in kbps. So that is 100 Mbps. Now next, that serial interface we have used. So you can check the bandwidth here, that is 120 kbps. So what we can change the bandwidth of the interface, conf t, then go into the specific interface mode. So we have to check first that interface. Now that interface is serial 0/1/0. So serial 0/1/0. So we are in that interface. I'm changing the bandwidth by using bandwidth command, and bandwidth we need to give in kbps. So what we'll do, 120.0.0.0. So I have changed bandwidth here, and that is 120 Mbps. So it is more than that fast Ethernet. Fast Ethernet is 100 Mbps. So it's more than that fast Ethernet interface. So definitely now, while transmitting packet from that PC 0 to PC 3, or PC0 to PC1 to PC0, definitely it is going to change the path. It will take the path that is 10, 20, and 90. That will check. So bandwidth is changed of that interface. So now we'll give the same command reset 90.0.0.2 on that PC1's command prompt. So path you can check here. Now it has taken path 10, 30, 90. So we can say that if the bandwidth of serial interface is less than the bandwidth of this fast Ethernet, it won't choose this path, even though it is near, even though it is shortest path. It will choose 10, 40, 30 and 90 because the data rate or that bandwidth is more. So when once I changed bandwidth here 120, immediately it has changed the path, that is 10, 20 and 90. You can observe again 10, that 30 network, this one, and 90. So now the next that we want to see, next command, that is show command, that is we want to check the neighbors. So exit from this, exit, and next command, that is show IP route. Even you can give question mark here, you can check only the OSPF routers. So show IP route OSPF. So you can check here. Directly connected networks are not shown here. It is showing only which routers those are connected by using OSPF routing protocol, right? So that command is show IP route OSPF. Then next command, that is even you can check here how to check neighbors, which are neighbors of that particular router. Even that command we can give by using show, just wait, show IP, then OSPF, show IP OSPF, give question mark here. It will display border routers information, database information, then interface information, neighbor information. So we'll see the neighbor information by giving command neighbor. Next, what we can give, show IP OSPF neighbor, whether you want to see the details of the all the neighbors or only serial link connected neighbors you want to see. So just I will give command show IP OSPF neighbor and detail. So it will give you the neighbor detail list. Okay, that command is given on router 0. So which are the neighbors? So neighbor 60, the neighbor 90. Then you can check here in the topology from this router 0. Now this 60 and 90 it is shown because these are directly connected. So these are not, we can say, neighbors, they are directly connected to this router. So the which networks, those are adjacent. So that is 60 and 90, right? So even we can give command like instead of neighbor detail, I think database is also there. The next command, you just note down these commands because by using these commands you can again design this topology, and you can cross check all the commands. So neighbor list all, that in neighbor, then it is show IP OSPF list is not given here. So show IP OSPF, even we can check database. So show IP OSPF database. So you can check this database. If you remember that router sends the link state advertisement packet, and that packet format we have seen in theory. So that is link ID, then advertising router, age field was there if you remember, right? Age, then sequence number is used to avoid duplication. So this is show IP OSPF database. We have given that command on router 0. So router 0 is showing those advertising routers. So here you can observe that router state link is, there are different types of links we have seen: router link state, network link state, summary link states. So all these databases displayed here. If you remember, we have seen 5 types of links, right? So out of those, some databases or link information is given here in this format. So we can already covered all this part in theory. So you just once again do it and try to understand what is that network database and all. Now from OSPF, even we can change the intervals, that hello interval, and now I have told you how to change the bandwidth also. Even we can change the interval of that particular hello packet transmission. So that command you can give in a specific configuration mode. So you have to select a specific interface from these three, and you have to set the hello interval timing. But what is the thing, if you are changing the hello interval, for example, suppose for this FA0/0, if I am changing the hello interval time for this interface, that is a command is that IP space OSPF space hello interval space timer space 15. By default hello interval time is 10. If I made it 15, then that neighbor should have same hello interval time, otherwise adjacency will be down, that it won't otherwise. I will give this command here, you can observe. So time is running actually, conf t, then next I will select the interface, that int fa 0/0. So we are in a specific configuration mode. Command is ip space OSPF space hello interval space timer, or directly give time, that is suppose 15. I've given time, that is 15. So immediately you will get one message that adjacency won't be there, so just wait for some time, otherwise we'll give the same command because there should be some adjacent. Now here we have given that command fa0/0. If I give this command here on this router, that is router 5, so enable, so it is first, see, it has given that neighbor 40.0.0.1 on fast ethernet 0/0 from full to down, neighbor down, date time expired, interface down or detached. Here also we can we'll check here if any message got. Now you can see IP OSPF hello interval 15 I have given on router 0, and you can check here that neighbor was 60.0.0.2. that 60.0.0.2, that is nothing but this interface, FA1/1 of this router 5. So here I have changed hello interval time, that is FA0/0. So hello interval time should be same for each and every link, then only it can become a neighbor. So here hello interval time I have made it 15. So now it is saying this interface IP that is 60.0.0.2 I have given to this FA1/1 interface. So it has given message that 60.0.0.2 on fast ethernet 0/0 from full to down. So neighbor down, neighbor is down here. So we have to give same hello interval time to other interfaces also. So again I can reset the time for this. Again, I can give command, that is IP OSPF hello interval 10. So we will wait for some time. So you can see here OSPF-5 adjacency change process 1. That process 1 we have mentioned while configuring that OSPF routing protocol. So process 1 neighbor 60.0.0.2 on fast Ethernet 0/0 from loading to full loading done. So now it can exchange the information. It can become a neighbor of this that router zeros, that interface network. That interface network is this FA0/0 interface network is 40. So now it can become a neighbor of this 40 network because hello interval time is same. So here we have completed OSPF. So you can try with same area as well as with different area how to change the bandwidth that I have told you, and how to check the routing table, how to calculate cost that we have seen. Even you can change the cost of the serial interface, and again you can give that routing table command, that is show IP route, and you can check what is the cost, right? So here we have completed